All right, good morning. Welcome back. Hope you all had a nice restful break. This morning I'd like to start off with just kind of a quick overview of the semester so you guys kind of have some expectation of what to expect. Our second semester is quite a bit different than our first semester, whereas first semester revolves around pretty much all things trigonometry. Second semester is not so much like that. We do a little bit of stuff from first semester we'll carry over to second semester, the most important thing being unit circle. So you're still on the hook for unit circle. But even occasionally things like degrees, minutes, and seconds, some of that other stuff like that will also trickle over. But most of second semester is revolved around algebra instead of trig. So most students feel more comfortable with that because you guys have a better background in algebra than you did in trigonometry when you came into class. But the general overview is we spend just about 4 class periods on 6-1, 6-2. That's what we'll start here in a minute, law of sines and law of cosines. Truthfully, law of sines, law of cosines doesn't help you in college algebra, doesn't help you in calculus, but it has become such a common topic on the ACT that we do like to spend a couple days on it to make sure that you can get those questions right. So we spend just a few class periods on law of sines, law of cosines. We'll spend a couple weeks on something called limits, which is actually the first topic in calculus, but we spend more time on it, so it's a little bit easier, and it's mostly algebra based anyway, but that gives some of you a heads up or a head start for taking calculus next year, and we place that strategically at this time of the year because you'll be doing CAP soon, and it's good for you guys to get an idea of what calculus can look like. Then we'll spend like a good 4 weeks probably on logarithms and exponential functions. So you've seen those in Algebra 2, but you don't really know them as well as you should have, or as you need to for higher level math courses, so we'll go in depth on that. We'll spend a couple weeks on rational functions, vertical asymptotes, holes, horizontal asymptotes. Nothing that you didn't see in Algebra 2, but just a quick little refresh. Probably spend like a day or two on quadratics, maybe 1 day on linear functions, mostly things that you have seen. So typically speaking, second semester scores are higher than first semester scores. I'd say the average class grade is usually about 4 or 5% higher. Of course, that's not for everybody. Some people put in less effort second semester, but I tend to think that if you put in the same effort second semester that you put in first semester, you should expect about 4 or 5% higher. So anyway, so that's kind of what the semester looks like. So again, for most of you guys, just depending on your algebra background, that can make second semester quite a bit easier for you. But it does have some challenges. But this first little small unit, law of sines and law of cosines, is a nice, easy start. Most people start off with a very good grade with this stuff. Today, we are going to look at law of sines, what it is, when you can use it, and practice using it a few times, and then that's pretty much all there is to it. So this is 57. The note says 57. So you can see I asked that you continue on with your binder numbering, but to be transparent, I won't ask for anything from first semester. So if you want to take out items 1 through 56, put them somewhere safe, put them in an old binder, leave them at home, then that is perfectly fine and understandable. You don't have to carry it back and forth all the time, but we're going to continue on with the numbering. So the main difference between law of sines and law of cosines with what we did last semester is everything we did last semester, or most everything we did, is called right triangle trig. You always needed a right triangle, so you could do SOHCAHTOA to find side lengths, so that you could do inverse SOHCAHTOA to find angle measures, so that you could do Pythagorean theorem to find side lengths. Those are all great skills, but they all require right triangles. And not everything in life, in the real world, requires right triangles. Law of sines and law of cosines will work on what's called oblique triangles. Oblique just means triangles that are not necessarily right triangles. So this is the formula for law of sines. You can take the sine of an angle divided by its opposite side and set it equal to the sine of any other angle divided by its opposite side, or even the sine of the third angle divided by its opposite side. I tend to use, now this formula and this formula are the same thing, they just took the reciprocal of each side. I tend to use this if I'm solving for an angle, because the angle stuff is in the numerator, and then I tend to solve for, or start off with this one if I'm trying to find a side length, because the side lengths are already in the numerator. Doesn't really matter because they're basically the same, but that's how I will do it for consistency. Now, even though this is hopefully not needed, we don't even make you memorize the formulas for law of sines or law of cosines. Again, since this is really for you for the ACT, we'll provide you the formulas, but this is a pretty hard one not to know, even after you just do a few examples. But we do expect that you know when to use them. So you can use them anytime you have angle side angle or angle angle side. These two both give you, are applicable when you have two angles and one side length. And then sometimes side side angle. This is when you have two side lengths and one angle measure. So, in case you don't remember the difference between angle side angle and angle angle side from geometry, I'd like you to sketch a couple quick little triangles here just to highlight the differences and similarities. Angle side angle means you know two angles. So, I don't know, let's just make up something, 20 and 30. Bless you. Whereas angle side also needs two angles, so maybe 20 and 30. But the difference between these is the placement in the S. Here, the S is trapped between the two A's. We call this an included angle or an included side. You need to know that term, so I would write it on your paper. And so the side that you know the length of is trapped between the two angles you know. Whereas if it's angle angle side, this side is not an included side because it's not trapped between the two A's. So the side length you know the length of is not the side that's between the two angles. It would have to be one of these other two. This is angle angle then a side. This is an angle then a side then an angle. But anytime you have two angles and a side, law of sines will work. Side-side angle sometimes works. Again, this is a little bit of a throwback here. You don't really need to know this for us, but in geometry, the main ones you probably talked about were side, 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 angle, 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 side, and hypotenuse leg. These are a way to prove that triangles are congruent. So if I told you to make a triangle with 3 specific lengths, you would all have to make the same exact triangle. There would be no deviation. So that's why these two always work, because they prove triangle congruence. This is probably not one that you did because it sometimes works and sometimes doesn't. Depending on how big the sides are, depending on how big the angle is, you could get no triangles with those lengths, you could get one triangle with those lengths, or you could get 2 triangles with those lengths. This is what in mathematics is called the ambiguous case. We used to teach the ambiguous case and put it on the test. And if you ever take a college trade class, you'll probably have to learn the ambiguous case. But we don't make you guys do that anymore because they don't put the ambiguous case on the ACT anyway. And again, we're doing this all for the ACT. That being said, we will put one bonus question on that quiz over that. So if you are interested in what the ambiguous case is and how to work it, you can optionally watch that video where it explains it, but you won't be on the hook for that. Okay, on the back page, I've got 2 examples typed out and 2 examples that we're going to write out. So one example I've shown where someone solved for a side length, and then one example where someone solved for an angle measure. So notice, I mean, this stuff's not labeled, but maybe this was angle A, so this would be side A. So you can see they took the sine of angle A divided by the sine of A. And then maybe this was angle B and side B. So they took the sine of angle B divided by the side of B, and then they just cross multiplied. So x times the sine of 48 is equal to 10 times the sine of 55. Undid the timesing of sine of 48 by dividing both sides of 48 by the sine of 48. Threw this in the calculator, and this is where that answer comes from. So basically, if you know the formula and you plug it in correctly and your calculator's in degree mode, it's pretty hard to mess up. To the right of that, we've got an angle question, which is basically the same thing. Notice the sine of an angle divided by its opposite side is equal to the sine of an angle divided by its opposite side. So that's where they're coming up with this equation. And then to solve, they multiplied both sides by 10, or 12, sorry. They undid divide with times. That's why there's 12 there. And then the main thing you need to highlight or emphasize is this is not how big x is, this is how big sine of x is. So if you want to know how big the angle is, just like we did last semester, you have to do inverse sine of that stuff. And that's where the angle comes from. So there's two that have been typed up for you that I just took off the internet, but I'd like us to do two where we put pencil to paper as well. And then I have one area formula to show you, and then we can move on to the practice. Okay, so question 1 wants me to find the length of B. Completely optional, but if you feel more comfortable having a picture in front of you, then make a picture. Doesn't have to be super accurate or anything, but if you feel more confident with the picture, take the 5 seconds to make a picture. Okay, I know the law of sines formula says that I could put side A over the sine of angle A, and I could set that equal to C over the sine of C or B over the sine of B, just whichever one I have information to. So this is a piece of the law of sines formula. Now if I just go back and say, well, I know angle A, I know angle B, I know side A, you should notice that you are left with an equation with only one unknown. And for this problem, I would undo divide sine of 55 by multiplying by the sine of 55. So here's our exact answer, and I believe this is what the ACT does. I think they stop here. I think all the answers look like this, so you would pick that one to solve for side B. But we need to actually practice typing this in so we can round it. Some of this may not go in the calculator the way you expect it to, but if your calculator is in degree mode and you type it in correctly, it's about 11, which should make sense because if a length of 10 was opposite 48 degrees, you know this side was opposite 55 degrees, so it had to be bigger than 10. So 11 seems reasonable. Okay, questions about that first example before we look at the second one? Everybody okay with that one? Okay, and then one example of what would be different if we tried to solve for an angle. So once again, I don't usually draw out the triangles. I just want you to see that it doesn't take but just a second to do so. And then part of the law of sines formula says that I could take the sine of angle B, divide by the length of B, as long as I set it equal to the sine of A over the length of A, or the sine of C over the length of C. All I have to do is multiply both sides by 2, to get it to sine b equals. But what I was trying to say with that written out example, the part you need to be careful about, this is guaranteed to be a number between -1 and 1 because that's the range of sine. This is not what b is equal to, this is what the sine of b is equal to. B is going to be the inverse sine of that. So again, assuming your calculator is in degree mode and assuming you type it in correctly, you should be finished. And of course that should be a pretty small angle because that opposite side is pretty small. If B is only 2 and A is 14, then angle B needs to be quite a bit smaller than angle A. Okay, anything you'd like to ask about finding an angle from example 2? Okay, we also sneak in 2 area formulas. We do one area formula in 6.1 and a different area formula in 6.2. So that would be the last of our notes. This is an area formula that is useful when you have side angle side. And I have seen this on ACT stuff, and it's very easy to use, but you probably have not seen it before. So when you do area of a triangle, the one that you should know is 1/2 base times height. But what you need to understand is that the height can change. And in geometry class, your teacher probably said the base is this number and the height is this number, solve for the area. But sometimes we don't know the height right away. So let me tell you what the new formulas are, these 3, and then I'll show you where one of them comes from. Not that you need to derive it, but so that you can see it's just a form of this. One of them could be 1/2 AB times the sine of C. Another one could be 1/2 AC times the sine of B. And what's the only other possibility? BC sine of A is almost right, but don't forget the 1/2. I also forgot the 1/2 first period in one question, so that 1/2 is easy to overlook. So notice side angle side. You have to know 2 side lengths, either AB, AC, or BC, and the included angle. The angle between those 2, the angle in between those 2, and the angle in between those 2. Now, the reason why I'm not going to derive all 3 of these, I'll just show you one of them. But if I call this generic ABC, most of you guys would say that B is the base, because you tend to say the thing on the bottom is the base. But you have to understand, I could turn this triangle and the base could be B, or the base could be A, or the base could be C, depending on how I want to turn it. It's going to change what's there. The height, though, is this distance. And the reason why these formulas are nice, even though you should have the trig knowledge now to be able to derive this, last semester we would have said, well, you've got a right triangle here. So from angle A, I could say the sine of A is opposite over hypotenuse. And this side would be C because it's opposite angle C. So if the triangle is oriented this way, then his height is C times the sine of A. So when B is the base, over here, when B is the base, the height ends up being C times the sine of A. And again, I'm just getting that by drawing in the height and doing a SOHCAHTOA equation to solve for the height. But if you know these formulas, you can skip that. Anytime you have 2 side lengths and the included angle, you do 1/2 times 1 side length times the second side length times the sine of the angle in between those. And then you don't have to go through this whole process just to figure out one of those. So we throw that in too, but those are real easy because we basically give you the information you need and you just have to apply it. So Okay, switching gears here. 58 will be on a blank piece of paper, and you need to do vocab check 1 through 4. And then there's 9 practice questions that I'd like you to finish in class and turn in if possible. There's quite a few people today that finished that book assignment and number 59 worksheet. However, if you don't finish the worksheet in class, I'm fine with you finishing that up for homework, but the notes and the book work, I'd like you to please turn in before you leave. I think that you have enough time to do that. So, take a few minutes, get the assignment copy down, start the first few questions, and then I will interrupt in a bit to see if you need help with the first few. Okay, I'll start to bug you for a couple questions here in about 5 minutes. So try to get the vocab check done and maybe number 5 to see if you need help. Okay, let's do a quick little check-in here. So, any of the 4 vocab questions? Or question number 5, I think. I think that was the first real question, first exercise. Any of those you'd like me to go over and help you with? Yeah.
I already forgot, was on number 3, was it 2 angles one side or 2 sides one angle?
2 angles one side. Because you could have 2 angles and one side this way, or 2 angles and one side that way. Okay, everybody else is okay so far? Okay. Then I'll bug you again in about 10 minutes. So do your best to try to have maybe vocab check and then maybe 5, 8, and 11. But of course, keep going if you're doing well. Of course, you obviously need to be checking your answers as you go along too. Occasionally you guys are not putting these in the calculator correctly, which is okay as long as you catch it quick. But if you don't check your answers, you might just keep on doing it and getting up a lot of the same mistake.
It's not what it is.
Alright, it's been almost 10 minutes already, so any of the first few that it would be helpful for me to go over? Yeah. Number 8, okay. Okay, if you need help with 8, give me a second and then follow along with me. Otherwise, keep going. All right, so for 8, the directions ask us to solve this triangle, and solve means find all the missing stuff. So we're going to need to find side A, side C, and angle B. And of course you have the hint that this section's about law of sines, so you know law of sines is going to work somewhere. And you could start off by saying, I'll write out the law of sines. And then I'll start to plug in the stuff that I know. Looks like we know angle C and angle A and side B. And then we can start to see what our problem is. So of course we don't need to look at the whole thing of law of sines, we just need to look at part of it. Like if I'm trying to solve for side A or angle B, I would ignore this part of law of sines. I can't solve for side A or angle B or side C because any of 2 of these 3 that I said equal to each other are going to have 2 unknowns. So I've got to do a little bit more work before I can use law of sines. Luckily though, angle B, we can still use our old trick that all angles add up to 180 degrees. Assuming you're talking about a flat plane and not like on a globe or something, all triangles add up to 180. So you can do that to figure out angle B is 41 degrees. And you have to do that before you can use law of sines. Now that I know B is 41 degrees, I can use these 2 to solve for side A. And then I could set these 2 equal to each other to solve for side C. So side A, multiply both sides by the sine of 16. A is going to be 5.5 sine of 16 degrees divided by the sine of 41 degrees. Or 2.31. Normally I'd round the 3 decimal places, but the directions do say 2, so I'm just trying to be faithful to that. And then over here, I could set these 2 parts equal to each other, multiply both sides by the sine of 123 degrees. And then you know what side C is equal to. Throw that mess in the calculator. And I'm getting about 7.03. And of course the last tip I would give you, as I've been pushing on you for months here, especially a question like this where you spend a couple minutes on it, it would be crazy not to just make sure whatever side's your biggest side better be opposite biggest angle. Whatever side you think is the smallest side, it better be opposite the smallest angle. And if those 2 things are true, then by default the medium-sized side has to be opposite the medium-sized angle. It doesn't guarantee your answers are right, but it would guarantee that your answers are wrong if that's not true. So I'm going to guess, was it that you didn't find angle B first and so you didn't know how to move forward? Was that the issue? Okay, was anybody else going to ask about 8? Need something more specific before I let it go away? I will spare you, but there was like twice I think last semester where we had some questions where we had to do some long algebra work with systems of equations, like finding the height of a mountain and finding the distance from a road to a fire or something like that. And we did them, and I told you not to worry about them for any test or anything because in January we'd learn law of sines and law of cosines where it's much easier. So if you were to go back and look at those questions, using law of sines is way easier than trying to solve some of those system of equations with 12 steps. But still good algebra practice, so I still like you to see it. Okay. Anybody else? Vocab check 1 through 4, number 5, 11, or 37? Any of those that I can help with? Number 11? Okay. So 11's the first one they want you to solve that does not give you a picture. Again, make a triangle if it helps. Okay, I suspect one of the problems that you may have, especially since it's been break and you're kind of wrestling in all this stuff, but number 11 is the first one that throws a degrees and minutes at you again. So you have to remember that 83 degrees, 20 minutes is the same thing as 83 full degrees, and a minute is a 60th of a degree. So angle A is like 83.3 repeating. And you either need to type out all of the decimals, all 8 or 9 decimals in your calculator, or better yet, just store that in for A so that it keeps that exact. Then similar to the last question, you don't have enough information to use law of sines yet. Well, I take that back. You can solve for side A right now, but you're never going to be able to solve for side B or angle B until you get some more information. But looking at these two, I know 2 of the 3 angles of a triangle, so I can do 180 minus angle A minus angle C to find angle B. That's 42.06 repeating. Same thing, you either need to keep up with all those decimals or store that in your calculator. But now you can use law of sines. By the way, cannot use Pythagorean theorem, cannot use the SOHCAHTOA equation. Those only work on right triangles. So if it's a right triangle, go for it, but none of these angles are right angles, so this is not a right triangle. So I could pair up this information together, say B over the sine of B is equal to C over the sine of angle C. And so it looks like B would be 18.1 times the sine of angle B divided by the sine of angle C. Calculator would do that for me. And then I could pair up this information to solve for A, or I could pair up this with this to solve for A. It shouldn't matter, but I'm going to pick the C stuff with the A stuff because C was given to me. There's always a chance I had made a mistake in angle B or something, or side B. So to find A, divide it by the sine of angle A, and set it equal to B over the sine of B, or C over the sine of angle C, whichever one's more convenient to you. So it looks like A would be 18.1 times the sine of angle A divided by the sine of angle C. Again, I'm storing that information, so it's a little bit quicker for me to type in my calculator. But another question they ask you to solve. So take the extra 5 seconds. Make sure your biggest angle is opposite your biggest side and your smallest angle is opposite your smallest side. That helps me catch a mistake in first period today. But if you don't remember this degrees, minutes, seconds stuff, make sure you add a little bit more notes to your work because you will need that again in at least question 41. Again, we do less of this stuff this semester, but some of it we still use. Okay, is that good? Okay, is anybody else going to ask about 11? Have something particular? Then do your best. 37, 39, and 41 are the area formula questions, so I think those should go pretty quick. 45 is just asking you for like one side instead of all of the stuff, so I think that one should be pretty quick. So I don't know. In the next, let's say 10 minutes, try your best to get through at least number 45 if possible. And then I'll bug you for questions then. been almost another 10 minutes, so again, well, I guess anything, but specifically anything up through question 45 first.
Do 47.
Sure. Nobody had anything up through 45 yet, though? Okay. 47. Well, let me get the picture down. Okay. So I think I have a pretty good guess about what the problem is with number 47 is they want you to find the distance from this tower or station to the fire. I'm going to call it X, and the distance from the fire to this station, which I'm going to call Y. And of course we have a big hint that law of sines is going to help us somewhere in here, but to use law of sines we have to know a side length, like 30, that's the only side length we have, and its opposite angle, which I don't know, so I'm going to need to know this angle before I can pair it up with this side for law of sines. And then to find this side X, I'm going to need to know his opposite angle, which is not a problem, because if this whole thing's 80 and this is 65, then we know this much of it is 15, so that's not too much of an issue. But when I want to solve for Y, I'm going to need its opposite angle, and I only know part of its angle. So it all boils down to, you don't know enough about the angles, so you need to know more about angles, and really the only one that you can get easily is this 15 degrees. So, similar trick to what we did last semester. If you need more angles, and especially if the question has bearings in it, which if you look or read the question instead of just looking at the picture, this is a north-south line. This is a north-south line, so they have to be parallel. And if you have a line that intersects two parallel, a line that intersects two other lines, two or more lines, is called the transversal. If those happen to be parallel, then we have some geometry relationships. The one that I used last semester just for consistency was, I always did alternate interior angles. The interior means inside the two parallel lines, and then to alternate, I could do like the top left with the bottom right. That's just one option. But if those lines are parallel, those angles have to be congruent. And if you get some other angle information with the parallel lines, I think you'll think the rest kind of falls into place pretty quickly, because these make up half of a circle, so together they have to add up to 180. These three make up a triangle, so they have to add up to 180. And then if you look at the big triangle, they have to add up to 180. So take away the 15 here, take away the 65 plus 70 there. That leaves behind 30 degrees. Now, I'm going to finish the question, but I suspect that was the biggest problem. You did not have enough angle information, but because you had two parallel lines, there was a way to squeeze out one more angle, such as alternate interior angles. Again, you don't have to do alternate interior angles. I just use that one every time for consistency. So now I could find X by dividing it by the sine of its opposite angle and setting it equal to 30. I don't know, the 30 kilometers divided by the sine of his opposite angle. I've got all this information now. So this length, the one from Colt Station to the fire, would be 30 sine of 15 divided by sine of 30, which is about 15.529 kilometers. And to solve for y, I could do y over the sine of his opposite angle, which is 65 plus 70, 135. And then I could use these two, but there's always a chance I have a mistake here, so I feel a little bit safer using the 30 kilometers over the sine of 30 degrees. So y ends up being 30 sine of 135 over the sine of 30. And in the end, I ended up with all the information. So I would note biggest side, opposite biggest angle, smallest side, opposite smallest angle. And the same angle trick, using alternate interior angles to get a little bit more angle information, I'm pretty sure you need to do that on number 48 too, the last one. I might be wrong because I didn't do that one first period today, but I'd be surprised if you didn't need that. Okay, anybody have anything else to 47 before I take a different question? Okay, any others that you have ready to go? Okay, I don't know that you need this full time, but I'm going to wait 15 minutes for one last time to ask questions. Again, I would really like the notes and the book assignment turned in to Google Classroom before you leave today. If you just run out of time, then I will accept it before class on Friday. But your homework also includes that worksheet. The worksheet's pretty short, so those of you that finish the bookwork should just move on to it, but you don't have to turn in the worksheet by Friday. The other two need to be turned in.
mind if I get the second one?
Okay, let me give one last chance here. Anything else from the bookwork that I can help with? Okay, so just to make sure that you didn't miss anything here, you do need to have the notes and book assignment turned in before class on Friday, preferably now, so I can start grading them. Also, so you don't forget. And you need to do that short little worksheet sometime between now and Friday. You don't have to turn that one into Google Classroom yet, but I won't be given any more class time for it. So on Friday, we'll do basically the same thing, but with law of cosines. Law of cosines works with different information, different formulas, but it's also used to solve oblique triangles. And since you guys don't have to memorize the formulas, it's pretty easy going. So that'll be Friday. Next Monday, we'll have one day for you to review and try some questions where they're mixed up. Some are law of sines, some are law of cosines. And then next Wednesday, we will have that big quiz, small test, whatever you want to call it. And we'll be done with this stuff. So